Hi guys, welcome to another Chemical Earth video presentation for the preliminary chemistry course. In this video we're going to have a look at atomic structure and just some of the important characteristics of the atom. So there will be, I guess, a little bit later a bit of a look at the history of the different models of the atom. The one that we go with at the moment is the Bohr model. So in the Bohr model, there's a couple of important things that we need to be aware of. Firstly, all of the positive material is concentrated in the nucleus, and so is most of the mass. The defining character of the atom is the number of protons. The number of electrons change when different types of chemical reactions occur. Electrons can actually move from one atom to another. So those numbers are not constant. And we will later on in the course look at isotopes. And isotopes are elements that have varying numbers of neutrons. So the only thing that can actually define an element is its number of protons. Around this nucleus are electron shells. Now, theoretically, there are an infinite number of these shells, and as we get further and further away from the atom, they get closer and closer together. But we do know that it is possible to actually move an electron completely away from the sphere of influence of the atom, so that it actually attaches itself to a different atom. So it's not infinite. There is a place where the electron can move to be no longer within the sphere of influence. When we're drawing our electron configurations, we draw our electrons representing the little dots representing the electrons with a maximum number in each of these different shells. And you can see n equals 1, n equals 2, 3, and 4 as we come down. The different numbers of shells, and these shells are actually given letters to represent them. So the K is the first, L second, M third, and so on. Just as in a gravitational field, we need to put energy in order to move something against the field of gravity. So we need to put energy in to move an electron away from the force of attraction that it has with the nucleus. Where it starts from is called its ground state. So that is where it is, I guess, stable. Its energy level is consistent. In order to move it to a higher energy level, we have to add energy, and this puts it in an excited state. And an excited state is one where the electron is actually in a higher energy orbit than what it was before. Once it returns back to its original energy level, it will actually release that energy as a photon of electromagnetic radiation, which may actually correspond to a color within the electromagnetic spectrum. Within each of these shells are subshells, and we've started to very briefly talk about this before. The problem, I guess, is that whilst the Bohr atomic model explained a lot of things that the previous models were unable to do, it was Erwin Schrödinger that actually identified just some limitations in the Bohr model, particularly in relation to energy levels. And what that did was that it took each of these shells and it subdivided them further into subshells. And that was actually a slightly easier way of trying to organize how the shells, how the electrons are actually organized within the shells. Now, it's not necessary for you to know this in a lot of detail because in the preliminary course, we basically need to just understand something about how the electrons organized within the atom and how they move between atoms, or how they're shared between atoms that create covalent bonds. So it's not necessary to go into a lot of detail with this at this point in time. Just, I guess, be aware of the fact that different shells have different energy levels. We need to put energy in order to move an electron away from the nucleus, and energy is given out as electrons move back towards the nucleus. The conventional symbols that we use when we're looking at atomic structure then are these ones that you see. For any atom, for any element with the symbol X, there are two key features. The first is the atomic number. The atomic number is written by the letter Z. And so this is both the atomic number, and that is equal to the number of protons. As I said before, the only thing that actually defines the atom is the number of protons. Now, up above this is the letter A. The letter A represents the mass number, or the atomic mass of the atom. And this is equal to the total number of protons plus neutrons. The electrons have such a small mass that we need too many of them to really influence the mass number to any great degree, and so therefore we don't actually calculate our mass number based on the number of electrons. We simply add the number of protons and the number of neutrons, and that will give us the mass number. So when you've got these two numbers, A and Z, then we can work out the number of neutrons by subtracting A from Z. So that will equal neutrons. Z itself will equal the number of protons. And if we have an atom which is electrically stable, then Z will also be equal to the number of electrons. And this allows us to start to draw atoms, to identify the key features of each of the atoms, and then to use the information from the previous slides to actually start working on the electron configurations. So, here's a question. Can you complete the table below looking at each of the different elements? So let me start this one off for you, and then you can finish these. So aluminium is element number 13. So that means it has 13 protons. If one of the isotopes of aluminium is aluminium 27, then that means that it has 27 minus 13, which is 14 neutrons. It will have the same number of protons as electrons, so the electron number will be 13. And when this forms an ion, because of its position in the periodic table, aluminium forms a +3 ion. That is a positive cation. So I'll pop that under here, just in white, cation. Let me move to hydrogen. Hydrogen is number 1. It also has a mass of 1, so therefore it has no neutrons and 1 electron. And it can actually form a positive or a negative ion. It tends to more often form a cation, but it can form an anion as well. Carbon is number 6. Carbon 12. I'll put hydrogen 1. Carbon 12 has 12 minus 6, which is 6 neutrons. It also has 6 electrons, again, because same numbers. Carbon can form a plus or minus 4. One of the things about carbon is it is very versatile in terms of the number of different elements with which it can combine. And so therefore that plus or minus 4 is very important, partly because when carbon combines, it can combine with 4 other atoms in an arrangement like this, or it can form double bonds or triple bonds, and we'll see some examples of those later in the course. So why don't you grab the periodic table, have a look at these remaining ones, phosphorus, antimony, and uranium, and see if you can complete the table. Thanks for listening.